when you have put the object on the surface, so this is the tension force and this is angle theta. And surface resistance is UR. So in this case, maximum angle can also be calculated by equation. So tangent theta is equal to mu r. So therefore the theta is equal to tangent inverse mu r. So to overcome the friction, the angles are required is we can use the formula. So theta is equal to tangent inverse mu r. Mu r means the surface of friction, the coefficient. And by this way we can calculate the physical maximum angle to calculate the to overcome the friction. Now today's lesson is we will go to the uniform circular motion. Uniform circular motion. UR is the friction coefficient. UR friction coefficient of surface, and theta is the angle. Angle to the force. So by this way we can also calculate. And the next topic is uniform circular motion. Okay, uniform circular motion is one is moving with the velocity at the radius r. So this is the velocity v, and the radius r. So in this case, we can call it acceleration. This version is acceleration. Acceleration is we call it centripetal acceleration. So uniform acceleration motion at the velocity v. So that will be A is a centripetal acceleration. When you are moving, so this one will move through that direction. A direction, so A is a centripetal acceleration. B is a velocity. I is a radius of the motion. So A is a centripetal acceleration. I is a radius of the motion, and the B is a velocity. So this is the way that centripetal acceleration we can calculate. This is the circular motion. So in the meantime, we can also calculate for the force. So centripetal force can be calculated. So this becomes a centripetal force. So centripetal force is F. The formula is M into A. Force is equal to mass multiply acceleration. So this is the equation. In this case, force is equal to mass multiply v square divided by r. So this is equation. In this case, we can calculate the centripetal acceleration. A is equal to v square by r. A is equal to the v square by r. A is equal to v square by r is the centripetal acceleration. V is the velocity, r is the radius of the motion. So the centripetal force can also be calculated. Force is equal to mass multiply acceleration. So the mass multiply v square by r. So this is the way that we can calculate the centripetal force of the body. They are moving at the centripetal acceleration. You see, some body moving. When there's some body moving, so this is the centripetal acceleration. So this is for the hour force. Normally this object is opposite to the gravitational force. So this is the Fg. Fg is m into g. Fn is the centripetal acceleration. So any objects are moving opposite to the gravity can be calculated. So that will be the minus Fn. So this is for the Fn and the minus Fg. So Fn minus Fn minus mg. Minus Fn into minus mg is equal to m into minus v square by r. So this is for the centripetal accelerations are moving through the gravity. So in this case, this one is going to the gravity. So in this case, we can calculate minus Fn into mg, so m into minus v squared by r. This one is our centripetal acceleration. When you are moving, so the moving object for the centripetal acceleration. Normally, this centripetal acceleration Fn. So this Fn is the centripetal acceleration. So the movements are opposite to the gravity. We should use as this equation. Minus Fn into minus mg squared to m into minus v squared by r. So this equation. Minus Fn minus mg is equal to minus into m into minus v squared by r. So this equation. In this case, at the top of the loop, is the Fn 0. So in this case, the top of the loop, at top of the loop. So in this case, the Fn equal to 0. So we substitute minus 0 minus mg equal to m into minus v squared by r. So that this becomes a minus mg. It's a m into minus v squared by r. So m can cancel. So that v squared is equal to the g into r. And therefore, v is equal to square root of g into r. So in this case, g can calculate. G is at 9.81 and r is at 2.7 meter. Therefore, the velocity can be calculated. The velocity is at 5.1 meter per second. So this is the way that centripetal acceleration we can calculate. So now we can also calculate the force. So force is equal to m to. In this case, we don't know about the m, so we just assume that. So in this case, m is 20 per kilogram. So it's m is 20. V square is 5.1 square and radii is 2.7. So this time we can calculate the force by this way. So we can use that. This is the canvas. So here is a radar. So radar is this one is moving like this. So in this case, the static friction between the radar clothing and canvas is a 0.4. So this is between this one is a friction. UA is a 0.4. And so the cylinder radius r. So this one is this cylinder here. So this radius r. This means that this radar is brightens crossing this direction, and this is the radius, and this one is the canvas. So cylinder radius r is a 2.1 meter. So in this case, we have to calculate. So first situation. So that what minimum speed be minus the cylinder and the radar. So the radar is not to fall when the flow drops. This means that this is the radar is moving this direction. So that when the distance speed is high, he will not fall out. So this is velocity we have to calculate. So in this case, this is the friction involved. So therefore that we can calculate. So therefore the equation is minus Fn minus mg through m into minus v squared by r. So this Fn can be calculated. So Fn is equal to U into Fn. The equation we can calculate is that Fn is equal to mg divided by us. So this is for the centripetal force. So Fn can be calculated as mg divided by us. So therefore, minus Fn is equal to. So this equation minus Fn minus mg is equal to minus m into v squared by r. So that's equation minus Fn minus mg. This equation is m into minus v squared by r. So that equation we utilize. So in this case, we substitute here Fn is mg by us. So this is for the mg by us. So in this case, another thing will be fall as do not fall out. Do not fall out means do not fall means minus Fn us into Fn is equal to mg. So this is us and Fn into mg. This is for the do not fall out. So therefore that we write down the equation. This equation is minus Fn is equal to minus m into v square by r. So in this case, Fn we can substitute mg into mu s minus mg into mu s. This is minus m into v square by r. So we calculate. So what you get the thing is g by mu a is equal to v square by r. So the gr by mu a is equal to v square. So v is the square root of gr by mu a. So the gravitation is at 9.81. Radius is at 2.1 and mu a is 0.4. Then we get the velocity. This is 7.2 meter per second. So this is the equation we can get it. So this is for us a set of expression. So the writer does not fall out. That most equation we have to utilize that equation. Minus f into minus m into v square by r. So that equation we have to utilize. So that we substitute f is mg by mu s. So that two equation we utilize to calculate the velocity. After that, you also need to calculate for the centrifugal force. So centrifugal force is Fn you can calculate is equal to m into v square by r. In this case, right now mine is at 49 kilograms, so m is at 49, v is at 7.2 square, and radii is at 2.1. So by solving this one, you got the 1,200 newton. So this is for the centrifugal force we can calculate. Another one is the trap force. Trap force means the people are rising a scale. So this is people are rising a scale. So the scale between the pressure and force. For example, people are rising a scale. 3 minutes like this. So this is the expression between the scale and the root. So this becomes the trap force. So therefore means, so this is for the force between the scale. T is the trap force. So this becomes a T is the trap force. So in this case, that between the scale and the surface, therefore the friction coefficient. So this is CP. So this is for the friction coefficient. So trap coefficient. And A is the area between area and the surface. So this is area and this surface. So this is the A, the area between surface. Effective cross is the area. Effective cross is the area. Okay, V is the velocity. So this one moving at the velocity V. V is the velocity. So therefore can be calculated by equation D is equal to half into CP A into V squared. So therefore can be calculated by equation half into the trap coefficient multiply area multiply velocity squared. So this is the way we can calculate the trap force. So when the trap force is moving, so they have to overcome the gravitational force. So the body is suffering the gravitational force. So this is the trap force here, and this is the F is the gravitational force. Therefore, this trap force and the gravitational force are opposite. So we can write down the equation T minus Fg is equal to mass into acceleration. Because of the people who write this scale, they have to overcome the gravitational force. After they have overcome the gravitational force, they got the acceleration. So in this case, G is the trap force, Fg is the gravitational force, A is the mass, and A is the acceleration. So we can calculate by this equation. So this equation we can calculate. So now that we can use when the acceleration is 0, if A equal to 0, this means that the people is moving at the constant velocity. So moving at constant velocity. So in this case, A0, so you can calculate D minus FG is equal to M into 0. So then D minus FG is equal to 0, so D is equal to FG. Then you can substitute D equation, D equal to half into CP into A into V square. This is the FG. So then you can calculate the D. So this is the V square is equal to 2FG divided by CP into A. So the V is equal to square root of 2FG by CP into A. So this is for the constant velocity required to overcome the acceleration can be calculated by this formula. So this is for the therefore and acceleration formula. Even moving with the scale, we use that data relationship. Okay, the next one is the falling cats are reaching the first terminal speed, 97 km per hour. Where A is stuck in and then spread out. Evaluating the A, how fast the falling when it reaches new terminal speed. So this means that original velocity and the original velocities are. So this is running at 97 km per hour. So this is we can write down the equation. So B is equal to the this is a B is equal to half into CB into AB squared. So and then we can see the FG. So B is equal to square root of 2FG by CB into A. So this equation. B is equal to square root of 2FG by CB into A. So this is the velocity and force and surface area. So this is the relationship. So this means the cat is firstly walking here. This is cat. So this is surface area A1. After it is 4, go to another surface here A2. So we have to see the velocity. So in this case the velocity is V1 here. This is the V2 we have to calculate. This V1 is the origin given is at 97. 97 V1 at the area A1. After passing to area A2, we need to calculate the velocity V2. So that we write down the equation V1 is equal to the 2FG by CP into A. So square root of 2FG by CP into A1. And V2 is the area which is the best. So in this case, square root of 2FG by CP into A2. A2 is equal to 2A1. And therefore the V2 is equal to square root of 2FG by CP into 2A1. So we write down the equation ratio. So V1 by V2 ratio. So V1 and V2 ratio square root of 2FG into CP into A1 divided by 2FG CP into 2A1. Then we substitute here V1 by V2. So square root of. So this is 2FG CP into A1 multiply the CP into 2A1 divided by 2FG. So in this case, here we get it's a V1 by V2 ratio. So V1 originally is 97. So this is V2. So this began as a square root of 2A. So V2 can be calculated. 97 by square root of 2. Because of that, we change. So this began at 97 by 1.4142. So you got it 68 kilometer per hour. So this is the way we can calculate the V2. The next problem, a raindrops with the radius r is equal to 1.5 millimeter, fall from a cloud. The height is 1,200 meters above the ground. The Z coefficient C for the draw is a 2/6. So draw is a spherical. So of the fall density of the water is a rho W is 1,000 kilogram per meter cube, and density of rho is 1/2 kilogram per meter cube. So we have to calculate the speed of the draw. The speed of the draw is in this case we utilize the equation. The speed is we can calculate. This is what the dress is. V is equal to square root of 2FG divided by CP. This is for the coefficient of A multiplying A. So this equation. So in this case, FG also has to be calculated. So FG equation is equal to this equation. So FG formula is 4 by star pi into R2 rho W into G. So this is called as our FG equation. So we write out so that we substitute this equation here. So area A is equal to pi into R squared. So this is the area A. And CBA means that rho A is the original. So this is called as a PA. So coefficient of draw is a price. So CBA is a price. Those things are you substitute. So now that we substitute here, so that becomes as a square root of 2 and FG we can substitute 4 by 3 pi into R2 rho W into G. Divided by CBA is 0 by 6 multiply with A is a pi into R squared. So this one we can substitute. So now that we can write down the thing. So this becomes as a square root of 2 into 4 into pi. So range of R2 and R squared are you multiply you call it only R. Rho W into G divided by 0.6 into pi. So then you got the velocity here. Square root of 2 into 4 into pi. And radius is 1.5 millimeter, 1.5 into 10 power minus 3. And rho W, so rho W is 1000. And G is 9.81. Divided by 0.6 into pi. So roughly we got it 7.4 meter per second. So this is for that we can discuss. So this means that when the rain is have to overcome the air friction. So air friction have to overcome. So this is the formula to calculate the velocity of the rainfall. So it's a uniform circular motion. Uniform circular motion. So in this case, A can be calculated V squared by R. So this is for the centrifugal acceleration. So uniform circular motion is applied for the rounding a curve in the car. Rounding a curve in a car. Or two waves are opposite or up. So those cases are moving at the uniform circular motion. So when you are using the uniform circular motion, in this case we still use the same formula to make the calculation. So this is for the uniform circular motion calculation. We have to utilize this is for the arc. Arc for the radius. Arc radius is 2.37 into 10 power 6 meter. And at the altitude H is equal to 0.52 into 10 power 6 meter. So this is 520 kilometer. So 520 kilometer is 0.52 into 10 power 6 meter. So this one is rotating at the velocity v. The velocity v is equal to 10.6 kilometer per second. We have to calculate the acceleration. So acceleration can be calculated v squared by the pi in r. So in this case, velocity is 7.6 squared, and radius is at this and this. So this is r plus r of the r plus h. So this is 7.6 squared divided by 0.52 into 10 power 6 plus 6.37 into 10 power 6. So by solving this acceleration, we will 8.4 meter per second squared. So 7.6 also the 10 power 6. So 7.6 into 10 power 3 squared. Because of the meter per second, 7.6 kilometer per second is equal to 7.6 into 10 power 3 meter per second. More than we substitute, so we got this acceleration is 8.4 into meter per second squared. This is the way we calculate the centripetal acceleration. So tonight we're talking about the moment, the circular moment, and centripetal acceleration. So especially for the constant moment, we can utilize the centripetal acceleration for the orbiting the Earth. So next video I will talk about the work power energy. When you have put the object on the surface, so this is the tension force